So one of the things we like about this class is the fact that software is often the subject of high visibility stories and news events, and sometimes that gives us an opportunity to make some closer connections between things that you might be hearing about on the news or reading about in the news and things that we've talked about in this course. So we decided to adjust the schedule a little bit and do a little bit of digging into what's been going on with what I assume is everybody heard of, is that there's significant problems with a website that allows people to sign up for health insurance under the Affordable Care Act. So this is sort of a CS169 special report. Neither Dave nor I, this may shock you, we are not experts in federal procurement and contract negotiations, but we have been able to glean a lot of interesting information about what's going on here. We thought it'd be interesting to try to put it in front of this audience and tie it to things we've talked about. So let's actually start with a motivating question. Which number best describes the total number of lines of code involved in the Affordable Health Care or the Affordable Care Act web service? And let's assume that this includes if they take other pieces of code off the shelf and libraries. Let's count all of that together, number of lines of source. And as a guide, we've put up the number of lines of source in some other well-known and arguably mission-critical pieces of software, like the space shuttle. That's pretty important software. If it doesn't work, people die, things crash. A recent version of Linux, Windows Vista, and a really complicated banking software that would have to integrate with legacy bank systems and talk to international banks and stuff like that. So which number most closely describes? I can't believe you people are so pessimistic that you're saying 500 million. Yet that is the correct answer. According to the New York Times and a couple of other sources that we looked at, when I read that, I had to make sure that I had read it correctly, because that makes it, by nearly an order of magnitude, the largest project I've ever heard of. So let's lead into another question. According to the same New York Times article, one specialist said that as many as blank lines of software may need to be rewritten before the site runs properly. So it's not 500 million. OK, well, now you really are being too cynical. The reported number, the quote from a specialist was around 5 million. But if you think about what, 5 million lines of code, I mean, that's like half of Linux, right? That's saying half of Linux has to be rewritten before this will really work. Now, there's a lot. The software hasn't been published. Only small parts of the source code have been leaked. Details are starting to emerge about the process that was used to put it together. But we can still, based on the information that we can read, we can ask some questions to find out why things turned out as badly as they did. So here's kind of the executive summary. Here's where we're going to talk about this. One question you could ask is this a case where a smaller project or a set of smaller projects using Agile would have turned out better? And if so, is there some reason they didn't? If you're saying they should have used Agile, could they have used it? Or were they constrained in some way that they couldn't use it? And regardless of whether they used Agile or didn't use Agile, can we say anything about the quality of the end product? And again, when we talk about what's in the code, there's only small bits of the code that have been released. One piece that was released, there was a piece that was released on GitHub. It was subsequently withdrawn. There's another piece whose genealogy is uncertain, but at one point it appeared on GitHub, and somebody forked it before it could be withdrawn. So you can actually go check it out. But what's in the code at a high level? What does the system involve? So the idea of this site is that you can sign up for healthcare that is where there's government plans that are also available. Basically, the government is subsidizing healthcare in different states, but it's complicated by the fact that some states already have a state-level version of this. Other states have nothing at all. So they both have to provide logic to do it for the states that don't have it, and that's 36 states. And they have to integrate with the computer systems for the states that do have it, and that's 14 states. They also have to integrate with the IRS and the Social Security database, because your income and where you live and stuff determine what kinds of coverages you can get and how much subsidy you get. They also have to do identity management. So all of these systems have a notion of how they manage your identity, how you prove who you are. And not surprisingly, we already talked about third-party authentication, right? Your identity management is different on every system. So building federated identity management is part of it. And roughly, there's a front end, which is you interact with it, you set up your account, you can sort of shop for different plans and stuff like that. And then there's a back end that connects your application to all these different insurance exchanges. So what's in the code, or at least what's the parts of the code that the rest of us have been able to see who weren't part of the process. And again, a big disclaimer here is only a small part of it, as far as we know, is now publicly visible. And this is because somebody was able to snapshot it, fork it on GitHub before it was subsequently withdrawn. And the part that you can read is a combination of client-side JavaScript and server-side Node.js code. Here are some factoids that others and we have just based on the code. I'll give you the GitHub pointer if you want to look at it in a moment. But the JavaScript code doesn't pass JS hint. That's a code quality tool. It's kind of like Reek, but it's for JavaScript. So the code does not so well on that. There's no tests directory. So does that mean that none of the code is tested? Well, certainly this part of the code, if there are tests, nobody thought to check them in. There's no caching. So every time you visit any page on the site, over 2 megabytes of JavaScript are being served to you. And because there's no caching, it happens on every interaction. Right? So that's one way that things could be slowed down. And there's no minification. One thing we'll talk about when we start the JavaScript discussion is you can essentially compress JavaScript by renaming variables to have shorter names, getting rid of all the white space. And that doesn't sound like a big deal, but it can actually reduce the size of it by a factor of 3 or 4. And this is something that I would say it takes an hour to do, but actually in Rails it's done for you for free. You don't actually have to do anything to get minification. So the JavaScript is not minified. In fact, I thought it would be entertaining to look at some, so I brought some along. So this particular file is some of the code that is involved in handling the registration, the sign-up process. You get the idea. I'll just hold down the key until. Oh my gosh.
Is this hand generated?
I hope not. If somebody was paid to type this, then I'd be really mad. We're not done yet, are we? No, we're not quite yet.
You're only 35%. Yeah.
This is one of 20 files that gets served every time. OK, moving along. There's no content distribution network to serve static assets. One of the things you do if you're a big site and you have a lot of static assets, things that don't change, like JavaScript or pictures, is you could put those on a CDN and have copies of it served from all over the place so you don't have to serve them. That was not done. And as I said, there's no compression or minification of JavaScript. And a programmer who sort of on his own tried this found that he was able to improve the loading time by 75% just by doing that and making no other changes. So kind of low-hanging fruit. So the Standish Group is one of several consultancies that studies software projects and why they fail and stuff like that. And their most recent report, I can't remember what CHAOS stands for. Maybe Dave remembers.
It has the word survey and industry.
It's basically, they survey a large number of software projects. And kind of the high order bit from the most recent report is that for projects that are sort of $10 million or more in labor, only 10% of those projects came in on time and on budget. 52% were late or over budget or incomplete or some combination of those things. And 38% failed, meaning either the project was canceled before it was finished or the software was technically delivered, but it was so problematic that it ended up not being put into production use. And what they summarized it was that the real key to success is doing less for less. That if you have a big project, you should split it into a bunch of little projects. So with that advice in mind, and this is only the latest of a series of reports that the Standish Group has done, although this is one of the more striking results because it basically says the most reliable predictor of software failure is the size of the project. That's a pretty strong statement. So what about the contract that was used to build out this site? So it turns out back in 2007, 16 companies, including CGI Federal, which was one of the companies heavily involved in the Affordable Care Act site, qualified, meaning they sort of got signed off as you're now an approved contractor for a $4 billion project contracted by the part of the government that runs Medicaid and Medicare, which are services that serve economically disadvantaged parts of American society. And this contract is called, there's a specific government phrase, indefinite delivery, indefinite quantity, which basically means we're not sure how long it will take or how much work is involved. Right? Now, for software, that's not the end of the world. Right? We know that for software, this sometimes happens. And one of these companies, CGI Federal, is one of the ones that essentially what happened was they were already able, they were in essentially an advantage position to bid on the Affordable Care Act project when it came up. So they were one of the main ones that got it. 55 contractors total worked on the ACA website. $394 million was doled out to those contractors. The largest single piece of that was CGI Federal, which got $88 million to do the integration part and a lot of the back-end logic. And this company, if you kind of look them up, over the next several years, they have $8 billion worth of contracts already lined up to do other projects just for the federal government. So what happened with the website? Well, it's had a lot of problems, and a polling agency randomly polled 800 users trying to sign up. 50% of them were getting an error message, too busy, try again later. 25% got errors when they tried to create their accounts. 38% got messages to the effect that the site was down, like they couldn't connect. They got error messages through their browser. And only 19%, fewer than 1 person out of 5, actually was able to go through the procedure with no problem. Now, since that time, things have gotten better, but this is the screen that a lot of these users were seeing. And ironically, sort of a year or so before it went live, there was the CTO of Health and Human Services had been talking about code that was written for the front end, which, by the way, the front end part of the code actually worked pretty well. It's fast, it's built mostly in HTML, it's scalable because the browser does more of the work, it's secure, and by and large, a lot of these statements are true. However, that part of the code was done by 3 guys in a garage, quite literally. It was a small startup called Development Seed, and the only reason that they were able to get the contract is that they technically were the subcontractor of a company that was really in position to get the contract, but more about that later. So technically, what were the problems? When people started complaining about this, what sort of reactions did we get from Health and Human Services, the government office who's responsible for this site? Well, they pointed out a number of challenges, technical challenges of doing something so complicated, but I think our response, given this course and what we know about software, is that yes, these are challenges, but they're not new challenges. So one problem they said is we got more users than we expected. Setting aside the fact that for months we've been hearing about how many Americans this would help, right? And by the way, let me just go on the record. I support the Affordable Care Act. That's why I'm so frustrated that this works as badly as it does. But they said we got more users than expected. Well, Farmville got more users than it expected. And I'm not saying that this site is as simple as Farmville, but the idea of setting yourself up so that you can scale up and over-provision is one of the things that we already know how to do. And you might say, well, OK, but that's not a fair comparison because we have to talk to all these legacy systems. Farmville didn't have to do that. Well, airlines and banks, when they put their services in the web, they also had to talk to legacy systems, some of which dated back to the 70s and the 80s, like the systems here. And they were able to solve this problem overall pretty well. So again, not that it's an easy problem to solve, but it's not a problem that no one has ever looked at before in the context of a web service. And by the way, I would hope that if it really has to talk to 14 different state systems and 2 federal systems and who knows what else, surely somebody stubbed those APIs so that you could actually test the pieces of code in isolation, right? But we haven't seen that part of the code. OK, well, that's not fair because, as we all know, the databases can often be the bottleneck. And these are legacy databases running on older systems. Maybe that was the problem, right? You can't just scale your way out of it if the database is the bottleneck. True enough, but we also know that you can queue off these tasks, right? You can have somebody fill out their form, submit it or whatever, and say, come back later because there's a lineup for people trying to get to these databases. You don't have to wait for every action to continue before you finish serving the user. And we already saw this when we talked about having a service that relies on an external service. One of the pitfalls is if the external service is too slow, it sort of backs up everything behind it. And in that situation, what you do is you essentially make that part of the work asynchronous, and you have the user check back. Not enough time to test it. Well, it's hard. I don't know what to say about that. That's more of a risk if you leave testing until very late in the game. We've tried to teach that you should be doing testing not just as you go, but before you write the code. So the idea of not having enough time to do testing doesn't really come up when you do TDD the way that we've been suggesting. So if you leave the testing till the end, and if the requirements happen to change during the time you're doing the development, then yes, this could be a risk. So how is the HHS and the other agencies, how are they responding, and what is their plan to address some of these problems? Well, let's again go back to some of the stuff we learned earlier. Hopefully everybody still remembers Fred Brooks saying that adding manpower to a late software project makes it later. So what's happening with healthcare.gov? The tech surge. They're calling in a team of the best and brightest to fix it, right? Like an emergency upgrade. The team includes engineers from Verizon, for reasons I'm not sure about. Contractors and experts from the, I mean, it's no slam on Verizon. I just don't know what their connection is to the rest of the contractors. It includes software contractors and experts from the insurance industry, veterans of top Silicon Valley companies, although they didn't specifically mention which ones. And Kathleen Sebelius, who is the head of HHS, said that this new infusion of talent will bring a powerful array of subject matter expertise and skills, et cetera, to people who have experience scaling big IT systems. You know, one wonder, if they're calling them the best and brightest now, you have to ask where those people were when they were building the thing. But we'll come back to that because there's actually a good reason for why that's the case. But at any rate, you might be skeptical that given Fred Brooks's experience, which is based on you know, one of the most highly visible complex projects of its time, that sort of adding a bunch of people after the fact, you know, how much good is that going to do? What else? Well, how about code reviews? If you've read or have heard about the kind of open source manifesto, the Cathedral and the Bazaar, one of the statements in there is, with enough eyeballs, all bugs are shallow. If you've got enough programmers looking at a piece of code, somebody will find that bug that many other people may have missed. Yet, unfortunately, even though part of the code was originally posted on GitHub, it was subsequently withdrawn. Now, the claim is that one of the reasons that happened was users were confused about what was the front end, what was the back end, and people were filing GitHub issues. You know how you can do the issues in the GitHub wiki? People were filing issues against the front end code, even though the issue had nothing to do with the front end. It was all in the back end. And they were getting inundated with issues, and as a result, they just decided to pull it off of GitHub. That may well be the reason, although I wonder why they didn't just turn off the issues feature of GitHub. I mean, that's another thing you could do if that was the problem. Somebody did fork one of the repos that contains some code that is not the integration code, but is also not the code that does just the user interface front end. And if you're interested, you can go browse it on GitHub. He's doing pull requests to try to fix it. He claims to be within a few days of getting a version that he can run on one machine, one really big machine, I guess. Division of labor. When we talked about user stories and how to work on your app, we said don't divide labor based on front end, back end, because then you don't have anybody who has ownership end to end of the whole story, including the performance. Well, unfortunately, the way the contract was structured is there was a front end contract and a back end contract, and they weren't allowed to talk to each other. Presumably, this rule is a holdover from the fact that the contracting regulations, of which there are 6,000 pages, come from hardware procurement, where once you've specified all the hardware requirements and there's different contractors building different pieces, maybe it's because you don't want them to be able to get together and say, you know what, if we did the following thing, we could sort of inflate our costs. So maybe it's there to prevent collusion. But in software, this is a disaster, right? You've got two teams of people that are going to have to integrate. And yes, they should have a good, clean API between them. But the fact that they're not allowed to have technical communications seems ridiculous, right? It's just a poor match for software. The front-end code was delivered early. It's generally very good code. It's got a very nice UI. But unfortunately, there was no ownership end-to-end of any of these performance issues. And the back-end integrations in particular were very difficult. And apparently, that's where the insufficient testing happened, because stress testing would have revealed that this might have been a problem. We all know the pitfalls of customers changing their minds, as they're so often wont to do. And the kind of pitfall is, even though you built the thing right, you didn't build the right thing. Well, according to various newspaper articles, in the last 10 months before the launch, 7 different changes to hardware and software requirements were submitted. So even though under the procurement and contracting rules, once a contract has been awarded and accepted by the contractor company, they're not allowed to change what they see as the requirements. So, you know, once I've agreed to do something, I can't make changes to what the requirements are, but the customer can still make changes. So we have the same problem, right, where the customer is going to change their minds several times, plus the fact that the passage of the law was turbulent, and, you know, a lot of specifications probably didn't even get done until much later than they otherwise would have, because nobody was sure if it was going to be the law or not. Can you estimate how much all of this costs? Well, in the real world, we know that there is a need to estimate the cost before the customer can agree to the project. You want to do some of that. But you know, again, going back to the agile point of view, if you get into a situation where quality, schedule, and scope cannot all be maintained, you have to decide which two you want, right? You can say, we're going to keep high quality code, stick to the schedule, but that means some features are going to be left out or might be late. We're going to delay those features. So one implementation might have been roll it out for some states initially, or roll out for some features initially, and do a graduated rollout with the others later on. Or you could say, we don't want quality to suffer, and we really need these features, but then we have to be willing to slip the schedule in order to accommodate it. But of course, the way politics works is a deadline had been assigned, and on this day, the website will be live, and all Americans will be better off for it. And they couldn't really go back on that, right? So Changing the schedule in this case was a non-starter. Presumably, you'd want to have high-quality code, so you could argue that changing the scope might have helped. So unfortunately, they tried to insist on all three. They set a rollout date. It was set in stone. It was widely publicized. They demanded an upfront plan, in part because, as we'll talk about momentarily, federal procurement rules require that. And then they committed money. Here's how much we're going to pay the contractor to do this work. What else? Well, incremental rollout. When we start talking about DevOps, we're going to see that there's a really nice mechanism called feature flags that all major successful SaaS operators use when they want to roll out major improvements to their site. The idea is that you can put these flags into the software so that you can roll out features a little bit at a time, or if you have a new feature, you roll it out to a few users at a time. Maybe 10% of the users get the feature, and if nothing horrible happens, then maybe another 10% get it, and then you sort of gradually build up until it's rolled out on your entire system. In contrast, this site was sort of, it has to go live for everybody, for all states. It all has to happen on the same day. And we're going to basically encourage people, don't even have coffee. Just wake up and go sign up right now for healthcare. I mean, they basically guaranteed that we're going to get a flood of traffic on a site that had never been stress tested rigorously. We had this checklist of when might Agile be a good idea versus when might plan and document be a good idea. Now, this project doesn't sort of come down definitively on one or the other side. For example, it is a system that has to exist inside of a regulatory environment that's pretty complicated. It probably will have a long product lifetime. But in general, one might want to make a case that, look, if you had split this into smaller projects, could you have used Agile on at least some of these, given all that we know about smaller projects and this methodology being more likely to succeed? So if that's the case, why is there no evidence that Agile was used on any part of this project? And from talking to a number of colleagues of ours, including some here on campus who have direct experience with this, a big problem is that the federal procurement process, especially as it relates to software, is basically broken. It's incompatible with the reality of building good software. So there's sort of 58 preferred providers, companies that are already sort of in a good position to get bids. And why are there so few? Why is your choice limited to these 58 companies rather than just going out and hiring smart people? Well, there's 6,500 pages of regulations. There's a very complicated process of what all the dots, the I's you have to dot and T's you have to cross to even get a contract. And indeed, well, I'll show you on the next slide a quote from the guy who runs this small company that did the front end quite successfully. He said, if we had to actually bid on the contract ourselves, I would have had to hire lawyers and grant writers far in excess of the number of actual engineers, and I have no desire to run that kind of company. So they essentially went under the umbrella of one of these 58 companies and acted as a subcontractor to them. There's also, on the part of contractors, there's a lot of fear because there's so much money in these contracts. If your company doesn't get the contract, you're motivated to try to find reasons to complain that either the contracting officer who chose your competitor somehow broke one of the rules, or that your competitor in executing the contract is not sticking to the rules. And the rules are so complicated that you could probably find something. So there's this culture where there is fear on the part of the contractor that even once you've got the contract, it could be taken away or you could be penalized or fined. And on the part of the contracting officers, that when they make a decision, when they pick somebody, they're going to be subject to all of these complaints and protests from the people who didn't get picked. So what does that lead to? It leads to a situation where you got to try to cover your butt, right? So you need to make a choice for which you won't get fired. And by the way, all of these companies that are the preferred providers spend a lot of money lobbying about issues that are going to result in projects that have to be done and stuff like that. So you could argue that there's some conflict of interest there as well. More to the point, the contracting rules essentially make it illegal to do agile development. So I mentioned this quote from Eric Gunderson. Development Seed is the name of the small outfit that did the front end. And part of the problem is the procurement rules say once you've accepted the contract, you can't change in midstream what your interpretation is of what you have to deliver. If you said, I'm going to deliver X, Y, and Z, you can't change that. But the whole premise of Agile is that, especially when the customer might change their mind, you can go through these sort of renegotiations to say, well, actually, we do have to change the schedule, or we do have to change the deliverables, because otherwise, you won't get high quality. So if you have a system where you're forbidden to do that, there's no possibility you can run an Agile project without automatically breaking some of these rules and thereby risking losing the contract. So why do you use the waterfall process? If we know the waterfall process doesn't have a great track record, especially for these big projects, why do you use it? Because it's easy to procure for. because it is a safe choice given the way the procurement rules are set up. Spec the whole thing in advance to the nth level of detail, pad all the estimates, have a plan, and be able to claim that somebody could get nailed if they don't follow the plan anymore. And I think to a lot of us, saying that you should procure using waterfall because it makes procurement easier is like saying you're going to look for the keys under the lamppost because that's where the light is brightest, right? It's not necessarily the best way to solve the problem. So based on what we've read so far, I guess here's how we would summarize. Absolutely, this is a complicated system. It is, maybe it doesn't need to be 500 million lines of code. That number kind of blows my mind a little. But it can certainly, I could easily imagine it being tens of millions. Nonetheless, I have not yet read about any technical challenge that is fundamentally new, that is different from a challenge that accomplished SaaS companies have not already overcome, and in many cases, not just once, but multiple times in multiple different systems. So they're not new challenges. Splitting into smaller projects might have helped. Unfortunately, the contracting rules seem to forbid doing that if your goal is to use Agile to work on the smaller projects, because essentially the fact that you can't make any changes once you accept a contract means that Agile is, for all practical purposes, illegal, right? You could risk getting yourself sued by choosing to adopt a methodology that is known to be good for doing smaller projects, and knowing that smaller projects as chunks of a bigger project are more likely to succeed than a big project that is spec'd out monolithically. And unfortunately, regardless of whether you come down on, should they or should they not have used Agile, at the end of the day, one can certainly look at the code and make statements about, what is the quality of the product that came out of the process? Maybe we paid too much for it. Maybe the process that we used to develop it was not the best process, but did it at least produce something good? And from what I've seen already in the code that I've browsed through, there's stuff in there that you guys would lose points on if you made these mistakes. If you actually deployed a site that was going to production and you didn't do caching, you didn't do minification, and you didn't factor your application so that you could serve heavily used assets from other places, I mean, this is basic stuff. It's so basic that there's a chapter of our textbook just about it. And if that chapter is all you ever read in your life about this, you would know that you could avoid some of these mistakes. So whichever side of this you come down on, I'm glad the best and brightest are being brought in to fix the problem. Fred Brooks remains skeptical, I assume, that would work. But the bottom line is those people don't seem to have been around during as much of the development, because otherwise the code would probably look better than it is. So more on this breaking story as it develops.